3 in the morning. Production is on fire. Your dashboard says the checkout service is slow. Requests taking 4 seconds instead of 40 milliseconds. But it won't tell you why. You start grepping logs across a dozen services, SS etching into boxes, guessing. An hour later you find it, one database call, in one service, 3 hops away from where the error showed up. The information was always there. You just couldn't see it. That gap between something's wrong and here's exactly what's wrong is what observability closes. Welcome back to DevWise. Today, what observability really means, the 3 signals that power it, and OpenTelemetry, the open standard that's quietly become as fundamental to modern infrastructure as Kubernetes itself. By the end, you'll never grep blindly again. Let's begin. Let's settle the most misused pair of words in our field, because the distinction is real and it matters. Monitoring answers questions you knew to ask in advance. Is CPU above 80%? Is the error rate climbing? Is the disk filling up? You define these checks ahead of time. You set thresholds. You get alerted. Monitoring is essential, but it only catches the failures you predicted. Observability is the ability to answer questions you didn't know you'd need to ask. Why is this specific request from this specific user slow right now when everything on the dashboard looks green? You can't predefine a check for that. The question only exists once the problem appears. Observability means your system emits enough rich, connected data that you can explore your way to an answer you never anticipated without shipping new code to add a logline. Here's the clean way to hold it. Monitoring tells you that something is wrong. Observability tells you why. Monitoring is a smoke alarm. Observability is being able to walk through the house and find the exact wire that's overheating. You need both, but as systems became distributed, the why got dramatically harder, and that's the gap observability fills. Why did this get so hard? Because we broke the monolith apart. In a single application, a request lived in one place. A stack trace told the whole story. Now, a single user action might pass through 15 microservices, 3 databases, a message queue, and a couple of external APIs. When it's slow, the slowness could be anywhere in that chain. No single log file sees the whole journey. That's the world observability was built for, and the foundation of it is 3 kinds of data we call the 3 signals. Observability stands on 3 pillars, 3 types of telemetry. Each answers a different question, and the magic happens when they connect. Let's take them one at a time. First, metrics. Metrics are numbers measured over time: request rate, error rate, latency, CPU, memory. They're cheap to store, fast to query, and perfect for dashboards and alerts. A metric tells you the shape of a problem. Error rate jumped at 3:04 a.m., latency doubled, throughput halved. Metrics are your early warning system and your trend line. What they can't tell you is which request, or why. A metric is an aggregate, a summary. It says 5% of requests are failing, not this request failed because of that database. Second, logs. Logs are time-stamped records of discrete events. User 4471 logged in. Payment declined, cache miss. They're rich with detail, and they're what most engineers reach for first. Logs are brilliant for the specifics of a single event. Their weakness in a distributed system is that they're scattered. Each service writes its own logs, in its own format, to its own place, and stitching them together into one story across 15 services by hand at 3 in the morning is exactly the misery from our cold open. Third, and the one that changes everything, traces. A trace follows a single request through your entire system, end to end, recording every step as a span. Think of a trace as the request's complete itinerary. It entered at the API gateway, spent 12 milliseconds in auth, 200 in the order service, and, there, 180 milliseconds waiting on one database query. Each of those is a span, nested to show what called what, with precise timings. A trace turns the request was slow in to the request was slow here. in this span, in this service. That is, the superpower distributed systems were missing. And here's the insight that ties the pillars together. The three signals are most powerful when they share context. A spike in your latency metric links to the exact traces behind it. A slow span in a trace links to the precise logs that span emitted. You jump from what? The metric to where? The trace to why? The log? In seconds instead of grepping for an hour. 3 signals, 1 connected story. Holding that correlation in your head is the whole game, and making it actually happen, consistently, across every service and language, is precisely the problem OpenTelemetry was created to solve. So, how do you actually get those 3 signals out of your code, consistently, across a dozen services written in 5 languages, without marrying a single vendor forever? That's the problem OpenTelemetry solves, and why it's become a genuine industry standard. OpenTelemetry, OTel for short, is an open, vendor-neutral standard for generating and collecting telemetry, traces, metrics, and logs. It's a project under the Cloud Native Computing Foundation, the same home as Kubernetes, and as of 2026, it's the second most active CNCF project by contributors, behind only Kubernetes itself. That adoption matters, because a standard is only as good as the ecosystem behind it, and every major observability vendor now speaks OTel. Here's the old pain it removes. Before OTel, instrumentation was tied to your vendor. You'd install Datadog's agent or New Relic's library and weave their proprietary code through your application. Want to switch vendors? Or send data somewhere cheaper? Re-instrument everything, a project nobody ever has time for. That's vendor lock-in, baked into your source code. OpenTelemetry breaks that with one idea: instrument once, export anywhere. You add OTel instrumentation to your code a single time. It produces telemetry in a standard format over a standard protocol called OTLP. From there you can send it to Grafana, to Jaeger, to Datadog, to Honeycomb, to your own Prometheus stack, and switch between them without touching your application code again. Your instrumentation is yours, not your vendor's. Let me name the moving parts, because you'll meet them constantly. The API and SDK are what live in your application. The API defines how you create a span or record a metric. The SDK is the implementation that does it. And there are SDKs for 11 languages, so your Go service and your Python service speak the same telemetry. The OTLP protocol is the standard wire format that carries the data out. And the collector, this is the quietly brilliant piece, is a standalone service that receives telemetry, processes it, and routes it onward. Think of it as a smart post office for observability data. Your apps send everything to the collector, and it batches, filters, enriches, and fans out to wherever you've chosen. Change backends? Reconfigure the collector, not your fleet of services. That separation is the heart of why OTel ended the lock-in era. Let's make this concrete, because the best way to understand OTel is to see how little it takes to start. The fastest path is auto-instrumentation, and it genuinely feels like magic the first time. You install the OpenTelemetry packages, run a bootstrap command, and launch your application through the OTel wrapper. With 0 changes to your code, OTel automatically traces your incoming web requests, your database queries, your outbound HTTP calls, all the common libraries. You set 2 environment variables, a service name and where to send the data, and traces start flowing. For most teams, this single step delivers 80% of the value on day 1. Then, when you want to see inside your own business logic, you add manual spans. Here's the pattern. You ask the tracer to start a span, say, charge card, around the code you care about, and you decorate it with attributes: the order ID, the amount, the result status. Now that operation shows up in every trace, with your business context attached. The art of good instrumentation is exactly this: wrapping the operations that matter to your domain, and attaching the attributes you'll wish you had at 3 in the morning. A span named charge card with an order ID is worth 100 scattered log lines. A few habits that separate clean instrumentation from noise. Name spans for operations, not values. Get user, never get user 4471, because the ID belongs in an attribute, not the name. Add attributes liberally but deliberately, the identifiers and statuses you'll want to filter by later. And mind cost, traces can be voluminous, which is why OTel supports sampling, keeping a representative slice rather than every single trace. Sampled correctly, tracing overhead stays under 1%, and you still catch the patterns that matter. The result of all this is the trace waterfall, the single most useful picture in observability. Each bar is a span, its length is its duration, its indentation shows what called what. One glance and the slow step is obvious, the bar that stretches far wider than the rest. That 4-second mystery from the cold open becomes a single, amber bar, 3 services deep, labeled with the exact query. No grepping, just seeing. Let's go a level deeper on the collector, because it's where observability becomes operable rather than just instrumented, and it's the piece teams underuse. The collector is built from 3 kinds of component, wired into pipelines. Receivers take telemetry in, most commonly over OTLP from your apps. Processors transform it in flight, batching for efficiency, limiting memory, dropping noise, redacting sensitive fields, adding metadata like which cluster or region a span came from. And exporters send it onward to one or more backends. You compose these into a pipeline, one per signal, a traces pipeline, a metrics pipeline, a logs pipeline. Why does this matter so much in practice? Because it moves operational concerns out of your applications and into one place you control. Want to redact personal data before it leaves your network for GDPR or HIPAA? One processor in the collector covers every service at once. Want to cut your observability bill by sampling or dropping low-value spans? Configure it centrally, not in 15 codebases. Want to send traces to one backend and metrics to another, or switch vendors entirely, change the exporter, your applications never know. On deployment, 2 common shapes. Run the collector as an agent, one per host, or as a Kubernetes daemon set, sitting close to your apps to receive and forward. And often, a second tier, a gateway collector, a central cluster that does the heavier processing and talks to your backends. Apps to agent, agent to gateway, gateway to backend. It sounds like a lot, but each layer earns its place. The agent keeps latency off your app. The gateway gives you one control point for cost, routing, and compliance across the whole estate. The mindset shift is this: your applications should emit telemetry naively, just produce the signals, and let the collector make the smart decisions. Dumb apps, smart pipeline. That separation is what lets a large organization evolve its observability without ever redeploying its services. Let's put it all together the way you'll actually use it, walking an incident from alarm to root cause, the way the 3 signals are meant to work as a team. It starts with a metric, your latency dashboard alerts. P99 on checkout jumped from 40 milliseconds to 4 seconds at 3:04 a.m. That's the what. In the old world, this is where the grepping began. In an observable system, it's where the investigation begins properly. You click from that metric spike straight into the traces behind it, the actual slow requests from that exact window. This is exemplar linking. The metric carries pointers to representative traces, so P99A is high becomes, here are 10 requests that took 4 seconds, show me one. That's the where. You open a trace, and the waterfall tells the story instantly. 14 spans, 13 are quick, 1 stretches across nearly the whole width. A database query span, 3 services deep, in the inventory service, taking 3.8 seconds. You didn't guess. You didn't SSH anywhere. You saw it. The slowness has an address now. Then you go from where to why. That slow span carries attributes and links to the logs it emitted, and there it is, A query missing an index, doing a full table scan because a related deploy 3 hours earlier changed the access pattern. Metric to trace to log. What, where, why, minutes, not hours. And the part that closes the loop, the SRE part. You don't just fix it and move on, you feed it back. Add an alert on that database's scan rate so the metric catches it earlier next time. And, because you now have the trace, you can prove the fix worked by watching that span shrink back to 20 milliseconds. This is how observable teams turn every incident into a permanent improvement. Instead of the same fire rekindled monthly, the data didn't just resolve the outage, it made the next one less likely. Let's land it with the habits that make observability a strength rather than an expensive data swamp. 1. Standardize on OpenTelemetry. Today, it's the CNCF standard, it's vendor neutral, and instrumenting once means you never re-instrument to switch tools. Even if you love your current backend, OTel keeps you free. That freedom is leverage at renewal time. 2. Start with auto-instrumentation, then add manual spans where your business logic lives. Get the 80% for almost no effort, then invest in the spans and attributes that map to your domain. Don't try to instrument everything perfectly on day one. 3. Correlate the 3 signals. Don't collect them in silos. The value isn't metrics, logs, and traces separately. It's jumping between them on shared context. If your tools can't take you from a metric spike to its traces to their logs, you've bought 3 dashboards, not observability. 4. Control cost deliberately in the collector. Telemetry can outgrow the systems it observes if you let it. Sample traces sensibly, drop low-value data centrally, and treat your observability bill as a thing you design, not a surprise you receive. 5. Instrument for the question you'll ask at 3 in the morning. Every span you name well, and every attribute you attach is a gift to your future self. Mid-incident, exhausted. Good observability is empathy for the engineer you'll be on your worst night. Master those, and the panic of production is broken, and I don't know why becomes a calm, 10-minute walk from symptom to cause. That's the whole promise. Not fewer incidents, but incidents you can actually see. That's observability, monitoring versus observability, the 3 signals, OpenTelemetry, instrumentation, the collector, and the incident walk that turns 3 a.m. panic into a 10-minute fix. Build this in, and you stop guessing why production broke. You simply look and see. If this earned its 20 minutes, a like genuinely helps the channel reach more engineers, and subscribe for more calm, practical guides for the people who keep production running. Plan before you apply. Goodbye for now.